Welcome to Spring LIB.
In this question, we have a transverse traveling wave on a chord that can be represented by this equation: d equals 0.22 sine of 5.6x plus 30/14. And where d and x are in meters, and t is a second. So first we need to determine a couple things. What is a wavelength? What is a frequency? What is a speed? Magnitude and direction. We can tell that the direction is to the left because it's a plus sign. Usually if it's a minus sign, that means to the right. If it's a plus sign, that means to the left. Part D says determines the amplitude. That we also know because we can just tell that it's 0.22. And the last one is maximum and minimum speed of particles of the chord. Okay, so for the rest, we more or less need some sort of calculation. So let's first look at lambda. We have this relationship, so this is in the form of A times kx minus omega t. So k equals 5.6 with units, and the definition of k is 2 pi over lambda. So from here we have lambda equals 2 pi over k equals 2 pi over 5.6 over meter. This is 1.1 meter. And how about frequency? So we know omega, and the relationship between omega and frequency is omega equals 2 pi f. So f equals omega over 2 pi equals 34 per second over 2 pi, which is 5.4 hertz. And we can ignore this inverse sign because the sign only tells us the direction, and plus sign means go to the left. And the velocity v equals, we have lambda and we have f. V is lambda times f. So it is 1.1 meter times 5.4 hertz, which is 5.9 meter per second. So this, of course, admittedly, I have approximated the previous two answers already, so this might not be the most accurate answer. If you did not approximate these two answers, maybe if you use these two expressions to find the velocity, you might also find velocity equals 6.1 meter per second. So these are just run-off errors. And part D is amplitude. We already know it's 0.22 meter. The next question asks us maximum and minimal speed. If we look at the rod, when it rotates like this. And then these 2 points can move up and down. And these points, if it's a standing wave, these points will be stationary. So the minimum velocity is 0 because there are points that doesn't have to move. And what about the maximum velocity? So maximum velocity will be this much. That is the amplitude times the period. So this is the amplitude, and if we can have amplitude times frequency, the angular frequency, which is the same as the amplitude divided by the period, and that gives us the speed. But anyway, the maximum speed are these points that moves up and down. So these points have the same frequency as the as a wave itself. So that's why I just use d times omega. So that gives us 0.22 meter times omega. We already found, oh, actually it's in the question, is 34 per second. That gives us 0.5 meter per second.